Hi class, so today we're going to be finding the inverse of functions and analyzing their graphs. So let's go ahead and get started. When we talk about inverses, many of y'all may not know what an inverse is, but if you look at this diagram here, you'll see A is going to 3, B is going to 1, and C is going to 2. Okay, we will annotate inverses of a function as representing f of -1. This is that annotation. Okay, so what you'll notice here is now we have 1 going to B, 2 going to C, and 3 going to A. If you compare these two, what's happening is that your input and output are switching. Okay, we are going in inverse order or reverse order. Okay, so again, we are switching X and Y essentially. Okay, so now our Y value becomes our input and our X value becomes our output. Here I've listed a set of steps to help us solve the inverse relations. So we'll say set the function equal to Y. So a lot of times you'll be given a function f of x equals, and we're going to go ahead and switch it to y equals. We'll switch x and y. So now our equation will say x equals ... with some y. We'll solve using inverse operations, and then we'll graph. And we're going to go ahead and graph both functions. And the reason we'll graph both functions is we'll know that we were able to solve for the proper inverse if our graph is symmetric at y equals x. This is the symmetric line. Okay? And we'll do a couple of these together and we'll check our work using graphs. Okay? Let's go ahead and get started. So for question number 1, we get f of x equals 2x plus 4. And so what we're going to do is we're going to set the function equal to y. So we're going to say y equals 2x plus 4. Step 1, done. Okay, step 2 says switch x and y. So now we're going to have x equals 2y plus 4. What I did here is I just swapped these two. And we're done with that step. Now we actually want to solve for y. Okay, so we're going to want to solve for y here. So we want to isolate this using inverse operations. So if I want to isolate y, I first need to subtract 4 from both sides. We'll get x minus 4 equals 2y. These simplify out. And my next step is I'll divide both sides by 2. This simplifies out. We can see this as 1/2 x minus 2 equals y. And essentially, this should be written as f inverse of x is equal to 1/2 x minus 2. And this is your function. Okay. Now, what you'll see here on the graph that I have here, and this was done using Desmos.com. Okay, when we look at the original function line, that original function is this line here. And you'll see that it goes right through here. Our function, our inverse function, is this guy here. Okay. Now this green line, this is our symmetric line. This is y equals x. In other words, guys, what you want to think of symmetry is it's the line that acts like a mirror. Okay, it's the same distance. Okay, from here to here, it is the same distance from here to here, and vice versa. You'll see that. So we get here to here, or up here to here. So if you're able to graph your function and your inverse function, and you can slice it right in the middle with y equals x, you did that correctly. Okay, let's go ahead and do another problem together. So in this case here, we have a little bit of a fraction, not a big deal, guys. So we're going to go ahead and see this part here. It says set it equal to y. So we'll say y equals -5 over 3x. Our next step is to switch or swap x and y. So we'll say x equals -5 over 3y. Let's go ahead and solve. So if I want to simplify out this 3 in the denominator, what I'm going to do first, I'm going to multiply both sides by 3. So I get 3x equals -5y. Why does this happen? Well, 3 over 3 simplify out. That gives us 1 times -5 is -5. Our next step here, if I want to isolate y, I need to divide both sides by -5. So what we'll end up getting is -3x over 5 is equal to, this simplifies out, -5 over -5 is 1y. So really, the inverse of this guy here is g of -1 of x equals -3 over 5x. Okay, so our original function is this line here. This is our g of x. Okay, our inverse function, this g of -1 of x, is this one here. So they intersect each other here at the origin, and you'll see here that this guy here, this is our symmetric line. This is our f or y equals x, and it slices right through, and it's like a mirror to our lines here. Okay, so we're gonna go ahead and practice this some more tomorrow, guys, in class. We'll do 2 more problems like this. So the things that you really want to remember here is these steps that we have as we're solving. Okay. This is what we'll practice during your guided practice, and you guys will see this again as part of your independent practice and your exit ticket. Y'all have a good day, and we'll see you in class. Please do not forget to do your aligned homework assignment on Teams that aligns straight to this video.